from Peic, Tukuljac, Emil. Application of renewable energy sources in traffic bus station as green energy Iceland. Sorry for pronouncing the name. It's there, Emil.
It's okay. I'm glad that I can share new knowledge and information with honorable professors and scientists and colleagues. I will show you some new ideas. It's something what is really, what are you familiar with? I will check, is everything okay? I'm sharing, can you recognize the presentation?
Yes, we can see your screen, yes.
Yeah, it's application of renewable energy sources in traffic, especially bus stations, green energy island. Me and my colleague Zoran did something what is something recognizable, but with some new ideas. I will try to list all these things because in some cases when I did some slideshow, I had some difficulties. Is second page recognizable? Can you recognize introduction and application of renewable energy?
Yes, we can see the second page.
Okay. The use of renewable energy resources in urban areas is becoming more common. Our design solution offers possibility to supply energy to fully electric buses, especially at the adaptive stops. This is combination of solar energy and wind energy. My colleagues mentioned some things about support of solar system, but they didn't have the same success with wind energy. For that reason, this could be interesting for you because we are trying to harmonize usage of solar energy and wind energy. We thinking about convenience of usage of turnpikes or last stations on this bus system to charge the batteries of buses and at the same time to use renewable energy. And we would like to show some ideas and some new things. If you are looking in the left top corner of this picture, this is the roof of the bus station. On the top is a solar panel as a diverter of wind. It increased the efficiency of wind turbine and at the same time collect the energy from the sun. That is the way how we should harmonize the usage of solar energy and wind energy at the same time. Why on this way? Usually new buildings are with a small slope, with small degree between the horizontal surface and roof surface. It's usually up to 15 degrees. Here we show some table, and you can recognize the wind acceleration is dependent of slope of roof. If you are using this solar panel to increase the slope, and if we reach the 45 degrees, then we can decrease the speed of wind 2 times. And if we are looking the equation in the top part, in the lower part of this slide, you can recognize that we increase the power 8 times. If we increase the speed of wind 2 times, then this is good harmonization between 2 systems. Solar panel is better because we have a faster blowing of wind, and this decrease the temperature of solar panel and increase the efficiency of the panel. And at the same time, with increase of wind speed, we enlarge the power which we can collect from the wind turbine. At the same time, this special kind of spiral Savonius turbine is coated with flexible foil. On the right side, you can recognize the flexible photovoltaic foil, and we are using this flexible foil to coat the blades of wind turbine. And at the same time, we have huge solar collector and windmill. This gives a higher efficiency than implementation of independent
you can
systems.
change the slide.
Yeah, I will change the slide now. And we have at the same time collection of wind energy and solar energy, and at the same time exist the independent controller and charger from wind system and from solar system. At the same time, except the bus station, we can use the surrounding environment, this protective rail on the road, or this special protective wall against the noise of traffic to support this system, or special areas where are the big parkings, and then we can enlarge the capacity of the system. On this right side is the e-bus charging structure, and I will show you which kind of chargers we are predicted for this structure. Is recognizable this two-type e-bus battery charging system? Do you recognize that picture? On the left side, we have a pantograph, which we use to charge the batteries on the bus. First one is inverted when the pantograph is on the charger pool, and the second one is regular pantograph, which is on the roof of the bus. If we have this kind of charging, usually the buses are equipped with special camera which can observe the position of charging point, and then it could directly manage the driving of the bus, and then to easily contact the point where we have charging system. This combination gives us opportunity to use or grid and regular power, or solar power, or wind power. At the same time, we have possibility to charge the buses with a wire on the top, which is usually the pantograph solution, or from the bottom, we have possibility of wireless charging system. I will show you some details. Optional e-bus supplies are or e-bus stationary charging with wire connection and pantograph. Second one is e-bus charging in motion, partially trolley bus, or we have possibilities to connect bus with the power line of the tram. In that case, that is only the option. In some cases, if we have similar system, we have possibility to use tram net to supply the e-buses. At the same time, I mentioned that we can use or bus station or power wall as a protective wall with the photovoltaic system and wind generator on the surface or on lateral side of this structure. At the same time, we have possibility to use fence, power structure, or road rails which carry the photovoltaic component. And in that case, we enlarge the capacity of the same system. The second solution is connected with wireless charging. We have or stationary charging system or charging in motion. Of course, the last one is more comfortable, but the dearest one, this is most expensive. The pantograph system is present at the moment in Novi Sad and a few other large towns, where Siemens built the system with pantograph and charging structure. On the bottom section, we can recognize the charging from the concrete point, usually the station, or we can use the charging in motion. Of course, in some cases, we can combine the trolley bus, the bus, the e-bus, and the tram. Here is presented the wireless charging system. Usually we have four type of, or classified type of charging system, or capacitive wireless charging system, or permanent magnetic gear wireless charging system, or inductive wireless charging system, or resonant inductive wireless charging system. Why it's good? Because we don't use cables, and we have ability to charge during the moving, but it's more expensive solution. But we are closer and closer to this solution where we have high efficiency during this charging without direct connection of a consumer. At this moment, a bus, electric e-bus, and the charging system. Where is the position of hybrid panels and wind generator? As I mentioned, that is combination of solar panel and implemented wind generator with the foil which is on blades of the turbine. Then we have huge solar collector and at the same time possibility to collect energy from the wind. When we are using these panels, usually we are installing on unlisted buildings or garage of the utility company in charge of transportation, or we use these panels and put it on a main bus station where is the large canopy and where we have space to install these components. Or in some cases we have longer bus stops or some, as I mentioned, protective guard lines or guardrails and some other components. And in bottom section, it is recognizable how does it look like the photovoltaic canopy bus station with the wind generators. That is why I mentioned that we harmonize the usage of two types of renewable energy resources, because many engineers and scientists are thinking only about one type of energy. As our colleagues before mentioned, one of them mentioned geothermal energy, few of them mentioned photovoltaic energy, but we are trying to harmonize usage and to increase the quality of collection of that energy through this structure. If you are talking about a wind generator, we examine some things with Savonius turbine, which is at the moment in horizontal position. The axis of this, the axes are in horizontal position, not as regular Savonius in a vertical position. And we combine some of these things with 3 blades, 2 blades, 2 stages, and some other combinations with different kind of shape of blades on this structure. We use the spiral Savonius turbine because we can use, in that case, the lateral wind, which is blowing on lateral side of the building. I will just shortly return back on one of these previous slides, only to show you some details which I didn't mention before. You can maybe recognize A and B. That is the possible direction of blowing of wind. But in same case, we can use the C option when we have lateral blowing or direction of blowing. If we have a spiral turbine on this generator, we can collect some energy from that structure. That is the reason why this is interesting. Usually vertical Savonius turbine is not dependent of blowing direction, but if we change the blowing direction, then that is important if we would like to collect some energy. At the same time, we would like to analyze the performance of solar panel dependent of slope of panel, and it's recognizable that in our region it's around 30 degrees the largest efficiency of the system. That is the additional reason why we would like to change inclination of the solar panel. Usually everyone want to increase usage of renewable energy, but only by application of the panel on the roof. We explain why it's important that we think about the right position of the panel when we are trying to increase the capacity of the system and not to enlarge the surface of the panel. And if our largest efficiency is with 30 degrees about the solar panel, and if it's at the same time the diverter of the wind, then we can find that around 40 degrees is the largest efficiency of the system, because the solar panel is at the same time deflector of the wind, and it increased the power of wind turbine. At the same moment, we increase the speed of the air, which more efficiently cool down the panel and gives more energy. And at the same time, if it's a bigger slope of the panel, then it's collect more energy. That are few reasons which we are thinking about exact position when we are installing this structure and when we are trying to collect more energy from the system, and one system is supporting the other. That is the reason why we mentioned that we are thinking about harmonization of solar and wind energy collection. At the same time, if we use this renewable system to accumulate energy in any big battery or accumulator, then we must think about some usage of energy during charging and discharging, because it's good because we have on-site the possibility to charge the batteries and not lose energy during distribution of that energy through the line or net. But at the same time, we have some usage of energy. We are thinking about permanent collection of energy to the accumulator, and then we decrease the power which is necessary for loading of batteries. That process is permanent, and loading of or charging the batteries is only intermittent process, and that can give us opportunity to be charge the batteries from our system, which is usually on periphery of the town, where we have a really weak net and where we can have a problem. At the same time, we don't have a problem with surrounding buildings and other structure if we are thinking about real collection of energy. What is our conclusion? That the hybrid system mentioned in this paper harmonizes the option of source system with wind generator, but with complete harmony, which gives a mutual support, which is usually more than double rather mutually independent systems. An adaptive bus station can be used to charge e-buses and at the same time the infrastructure around this system. The station batteries are continuously charged, and then the bus batteries are charged shortly during the stoppage time. Or if we have short net or trolley system, then we can charge the buses during the motion. In case of necessity of usage of hydrogen, then we can apply the electrolyzer on this station and then to produce hydrogen necessary for new kind of driving system. That is dependent of our decision what kind of system which drive the e-buses or general the buses. That is the idea which we represent in this project. That's all, and thanks for your patience.
Thank you very much for your presentation. I want to ask you if it's only a project or applied on real life, on Novi Sad.
We had I could mention small solar system, which is 10 kilowatt the power, and 3 spiral turbines. And we didn't have a wind tunnel, but we examined with some funds and some measurements about wind speed and collected energy. And we will show the results in our paper, which we will deliver, as you mentioned, a little bit later.
Yes, thank you very much. Other